from where we left off yesterday. Yesterday we started basic 9. Okay, and we're moving towards basic 10. And here I want to give you guys some ideas. Okay, and then I will hand it over to the next instructor. And these ideas, and this is one of them, right? So let's recap what we have done yesterday. Let's recap what we have done yesterday. We analyze the method, right? We analyze why and how we do it, right? So the focus is on the sign, right? So in order to solve inequalities like that, and we use mathematical principles. So what are the mathematical principles that's relevant here? We said number 5 and number 6, right? Number 5 and number 6. But how are they used here? Well, if you look at the question we have used here, right? If you see how it's been used, first of all, the inequality we have, right? It has, well, let me put the summary here. The summary, right? Even though we just did one question, right? Even we just did one question. The question we have here is that it's in the form of A multiplied by B and less than 0, negative. So one side of the inequality is 0. This is very important because the same method you cannot use this method for if one side is 1 or one side is anything other than 0. Okay, look, principle number 5, number 6. Principle number 5 and number 6. It's all about, do you guys know what I'm talking about? Principle number 5, number 6? Yes, so please look at the principle number 5. Right? If A times B is equal to 0, right? And then blah, 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 right? Principle number 6 says, well, if A times B is less than 0, greater than 0, etc., etc., right? Do you guys see that? And even involve A divided by B larger than 0, A divided by B less than 0. So these are the issues that's being addressed. Do you guys follow me? So that if statement, or if and only if, right? Do you guys follow me? The inequalities in consideration, of course, it could have been greater than or equal to 0, where in that case, principle number 5 and principle number 6 are used at the same time. It would be less than or equal, greater than or equal, greater than or equal, less than or equal. You guys follow me? Principle number 5, number 6 combined would be this case, right? Less than or equal, greater than equal, and so on and so forth. Multiplication or division. So when we apply these principles, right? When we apply these principles, the examples we did is A times B less than 0. And this same idea can be extended to greater than 0, quotient greater than 0, quotient less than 0, and so on and so forth. So 5 and 6 combined, right? Principle 5 and 6 combined. And that will be this less than equal to 0. And you guys follow me? So to apply the principle, when we solve inequalities, we have to make what? Number 1, one side must be 0. one side must be 0. So the first step must be make 0. That's the method we're doing. The first thing you have to have a 0. Well, in our case, 0 is given. In other cases, 0 may not be given, but then you have to make 0. You have to make 0. Number 2, make a product. Make product. In this case, we studied the product was given, right? So in the case we just studied yesterday, 0 was given, product is given. What if the product is not given? You make a product. What is a make product? Factoring, right? So in some cases, we're going to see in the future, it could be you have to make product. This is why we study factoring for a very, very long time. Do you guys remember? Remember your past experience, you must have done factoring for extended period of time. You might have wondered, I don't know if you have you ever wondered, why did I do this, right? Why do I need to do factoring? Right? Have you thought about that? It's because of these two principles. And because the application of these two principles. Okay, so make 0, make product are these two important factors in applying principle number 5 and number 6. Right? And then the rest is just, applying principles. Number 5, number 6. So these are the major elements I want to point out. Okay, so let's take a second look, right? So solving inequalities is about sign. It's about sign. It's about the sign of the factors in this case and the sign of the product. Okay, it's all about sign. It's all about signs. What are the signs? There are only 2 signs, positive and negative, right? Positive and negative. All right. But I also mentioned to you, I want to give you the function perspective. So here I am going to give you the function perspective. This functions perspective is also very, very important, especially in today's day and time. Sometimes it could make the factoring could kind of, dwarf the factoring technique. Because in a lot of cases, factoring is very, very difficult, okay? The kind of factoring we have done, right? Mostly they're academic questions. What do I mean by academic questions? You saw those questions in school. When you are out of school, you start to, if you ever deal with similar math questions in reality, most likely they're very, very difficult to factor. Most likely, those questions in engineering, economics, finance, those mathematical models, if you can find them, if you apply similar issues to similar questions, most likely the factoring is very, very difficult, if possible. Okay, sometimes the factoring is almost impossible. But with modern technology, graphing is made much easier. Okay, graphing is made much easier. So in this case, right, the function perspective becomes ever so important. And as I'm going to show you, I think you might like that even better. Okay, so still solving this inequality. So I'm going to still taking this question. right? Okay. Solve that. The function perspective. The function perspective. And of course, we understand this is an if statement. This is still if statement for sure. Okay, it's an if statement, right? It's an if statement. If, right? If statement. If the product of two numbers less than 0, right? But the function perspective tells us that this is a function. We see this as a function. Well, it is a function whether you see it or not. Okay, by the way. It is a function whether you see it as a function or not. So as a function, okay, did I record? Okay. As a function, right? This is the rule. This is the rule of function. Okay, you can expand it, you can multiply this out, it doesn't matter. Okay, it is a function. The rule is such, right? This is the rule. So the if statement is telling us what? What does if statement tell us? Giving me the input, right? And this rule produces output. And what is the output? That's the output. And we want the output to be negative. Okay, that is, we want, okay, we know the output are negative. You have many outputs, right? Have many outputs. We know the outputs are negative. And what do we want? We want to find all the possible input. Okay, so what's wanted? All possible input such that the outputs are negative. And we know it's a function. It is a function, right? You can check by definition. For each input, there's exactly one output, for sure. Then with this perspective, what do we do? Well, as a function, we can graph this, can't we? We can find the x-intercept, y-intercept, can't we? Yes? Right? In fact, the graph of this function is at your fingertips. Boom. It's a parabola. It's a parabola. It is a parabola. You guys know parabola, don't you? Yes? Quadratic function. This was extensively taught in about its factoring, solving in intermediate algebra and elementary algebra. Okay, and in my modules, right, you see the title, Everything Quadratic. Okay, it's discussing about quadratic function. But unfortunately, I don't have time to go over those things with you. But there are recordings there available throughout the weeks. Okay, and feel free to watch them. And if your other instructors don't have time to cover, because depends on their time availability and the contents, then you can also study that. Very, very important function, right? So what does that mean? So you can get the figure, or you can sketch it yourself. You can sketch it yourself. Okay, so what are the important factors in the sketching? X-intercept in particular in this case. X-intercept in this case. How can you find x-intercept? How do you find x-intercept? I will talk about how you show your work, okay, for both methods, okay? How do you find x-intercept? You set output equals 0, right? We talk about those many times, right? We have done those, 22 functions, we find x-intercept, y-intercept for many of them, right? So how do you find x-intercept? Well, the output is 0. What if when is output equals 0? What happens if the output is 0? Right? If the output is 0, that means this guy is equal to 0, right? And what will be the consequence? The consequence, this will be principle number 5, right? Principle number 5. So x will be equals to -2 or 3, positive 3. What does that tell us? It tells us that on this parabola, okay, on this parabola, okay, so let me make it, on this parabola, okay, so let me make a little more adjustment here. Okay. On this parabola, where does the curve cross the x-axis? -2 here, -2, 0, and 3, 0. Okay, so there are 2 points. And these 2 points, when we put it on the graph, they should be circles. Circles. 2 points. Why these 2 points should be circles? Because we want the output to be positive. I'm sorry, we want the output to be negative. Where do you find negative outputs? The picture shows us clearly. This piece is positive. Output is positive. This piece, the output is positive. Which piece its output negative? This piece. This piece is negative output. That's what the picture tells you. The picture really tells you. So what are the inputs that make the outputs negative? Where do you find them? They're right here. So these are the inputs such that the outputs are what? Are negative. Do you guys follow me? So this is if we use the function perspective. And this idea is very powerful. Okay, I'm going to give you a couple of examples to show you the application of these ideas. Okay, so once we are able to identify the crossing, remember we talked yesterday, we talked about x plus 2 changes sign, x minus 3 changes sign. We have those ideas, right? What do we see now? If I bring the picture that we did yesterday over next to the picture we just did, right? So I'm going to put this over here. Okay. The picture we worked out yesterday, right, near the end, is this. Oh, yeah. Compare these 2 pictures. Compare these 2 pictures. Compare these 2 pictures. What do you see? What do you see? This is -2, this is -2. This is 3, that's 3. Yeah, do you see that? pictures are consistent, telling us what? Consistently telling us, these two pictures consistently telling us the product is negative between -2 and 3. So doesn't matter which method you use, does it? And from this, more method can be developed. Okay, I haven't even addressed those other methods. I haven't even addressed all these other methods. Okay, other methods can be developed. So you can see the power of principles and understanding the concept. Understanding the concept. Okay, so the picture we did yesterday is merely a simplified version to demonstrate the sign of the function, right? In the yesterday's case, we didn't graph the function. We didn't see it. We just considered as a product, right? In today's lecture, we see, oh, if you graphed it, it turned out the curve from positive, right? It changes sign from positive to negative, and this is the turning point. -2 is a turning point. -2 is a turning point where the output is 0. When input is -2, the output is 0. And there's another turning point, that's +3, right? From negative to positive. So 3 is a turning point. And at 3, the output is 0. Do you guys see that details? And these two methods produce the same answer, of course. It has to, right? Otherwise, something is wrong. So these are the two perspectives. So you can see the pros and cons of these two methods, right? The pros and cons of these two methods. The pros is that the function method is more visual. Is more visual. If you understand input, output, and that mechanism, you understand the nature of the question, the answer is obvious. You understand, because you always just, you either is looking for input or you're looking for output. Sometimes you know input, you look for output, or we know output, we're looking for input, right? And turning points. In this picture, you either have positive, you have negative, 0. Positive, negative, 0, just 3 kinds. You follow me? So you can see that step of making 0 is indeed very important, isn't it? You will see this idea used in calculus 3. Calculus 3. You know, when I was in college, in calculus 3, they were teaching this Lagrange method, right? Lagrange multiplier. At the time, I didn't understand why they make a 0. I didn't understand. And the teacher didn't explain it. It puzzled me for years. It puzzled me for years. Okay, because when we compare with 0, it's much easier. It's much easier to compare with 0 than comparing with 1 with 2, right? Yes, do you agree with me? It's much easier to compare with 0. You will see that method reoccurring in Calc 3. Okay, so this step making 0 and then make product and applying principles, 1, 2, 3 steps, right? So in this case, in the function idea, you still need to make a 0. Okay, you still need to make a 0. Okay, so far we haven't get to make 0 because they're already made for us. The function method still require us to know the point of crossing. So you need to know the x-intercepts. So by giving us the product form and 0 is made, it makes everything easier for us. We can identify the intercept easily. It's just a matter of understanding the nature of the question. But sometimes you have to make that 0 yourself. You have to make that product yourself. Then you say, what if sometimes it's hard to make the product? Oh yeah, sometimes it's hard to make product. Okay, but if you're lucky that you're going to encounter a quadratic form, you have a quadratic formula. Okay, the good news is the quadratic form show up a lot academically. Quadratic forms show up a lot academically. Okay, so before we move further, okay, I'm gonna give you some extension of these ideas, okay, as to other functions, right? So then I have all these pictures drawn and stuff like that. You say, well, how do I show my work, right? How do you show my work? The way to show your work, yesterday, and this much is sufficient. Okay, if you use this method, to observe sine, this much work is sufficient. Okay, you guys hear me? You need to tell the reader that you're working the sine of x plus 2, you're working the sine of x minus 3, you're working the sine of the product. And then you draw the conclusion that to make this, if this is true, then the solution will be that. Okay. I prefer the inequality. And as I told you this at the beginning of the semester, I want you guys to learn how to use inequalities well. Okay, that's the weaklings of a lot of our students. So the next method, right? What do you show? What do you show? Okay, so the steps to solve using function method is typically like that. Okay, you will say, if I solve, okay, suppose I solve this inequality. Okay, there's a lot of visual. There's a lot of visual in this case. You can draw the picture. Okay, you draw the picture, and then you're gonna mark the points. You're gonna mark these 2 points. This point is -2, 0, and the other point is +3, 0, right? And on your picture, you can mark that this is positive. This piece is a positive. This piece is a positive, and that piece is a negative. Okay, and then you can tell the reader the solution to that inequality are between -2 to x less than 3. So that's how much work you would like to show. Is that clear? Is that clear, everybody? So you do need to tell the reader, okay? In some cases, it might be necessary you show the reader how you find -2, +3. Okay? Then you can also add add a few words, right? You can say x plus 2 times that. If you don't introduce a function symbol, there are more than one way to show this, right? You can say crosses. You can say curve crosses x-axis at -2, 0, 30. Okay, and you can also tell the reader to find that, because sometimes you actually see that step in textbook, right? So you can you can also add that set this equal to 0, right? You can say, let me put it here, set that equals to 0, right? Then x equals to -2 or x equals to +3. If you show this much work, it's usually sufficient for the reader or your professor to understand. You understand what you're doing. Because whoever give you grades, they need to make sure you demonstrate understanding, and so you need to have necessary explanations. You follow me? Any questions? Any questions? So this is the function perspective. This is function perspective. Okay. In fact, both methods is about, how you find the input to find and to ensure the output is negative. Ensure the output is negative. From these ideas, okay, there will be another way there's another method that's taught in the textbook. What they do is they make a table. Okay, so the textbook method. Okay, I'm not going to extend on textbook method. So let me clean this up. Just to give you a mention of the textbook method. The textbook method is pretty much primarily based on the first method I taught yesterday. Okay, the textbook method. Okay, this is a textbook method. The textbook method, they basically make a table. Okay, a couple columns. I think this will be sufficient. They make a table. Okay, they make a table. They make intervals, right? One of the intervals is between -infinity to -2. You still need to identify -2, +3 though. You still need to identify -2, +3 though. Okay, so you still need to identify points where sign changes for expressions. Okay, so the 3 interval that will be in consideration, they will do these intervals. Okay, and they pick a test point. They pick test point. They pick test point. Okay, say for example, in this interval, they will pick test point. They'll pick test point -3, and here they pick 0, and so on and so forth. And they look at the sign, right? They will look at the sign. The table is more or less like this: the sign of x + 2, the sign of x + 2, and the sign of x - 3. Okay, sign of x - 3, right? And last, that will be about the sign of the product. They do the table form. They do the table form. This is the typical in the textbook. If you've seen it, and it's being taught. So I'm going to just briefly mention this. See here, I'm going to choose -3. I'm going to choose a 0 in this case, right? Here, I'm going to choose 4. So plug in this number in x + 2, then I'm going to get a negative. Here, I'm going to plug in 0 in x plus 2, I'm going to have a positive. And plug in 4 in x plus 2, I'm going to get a positive. Right? Am I right? Okay. And you do the same thing for x minus 3. So this is going to be what? This is going to be negative. This is going to be negative. This is going to be positive. And in the end, the product is going to be what? Negative times negative is positive. And positive times negative is what? Is negative. Positive times positive is positive. So it's the same idea. Do you guys see that? But these are the 3 ways of presenting the solving similar questions. And you need to realize it's all about signs. And there's the fourth method. There is the fourth method. Okay. I'm not going to talk about the fourth method unless I see people use it. People use that because that's going to take too much time, and it's usually not taught. If you are curious about that fourth method, the fourth method is using logic, still based on principle number 4, number 5, and number 6, by using logic to work it out. Okay. So I'm not going to go over that because we just have so much time. Okay. Now, each method has a pros and cons, right? But they all have certain numbers we need to find. All 3 methods we need to identify the points of 2, -2, +3. But the method we talk about today, that the function perspective, as I said earlier, in a lot of cases is much, it should have been taught more. I would say it should have been taught more, especially with today's, advanced technology and the availability of graph. But that's why I bring this up. For example, okay, if I ask you to solve for x, right? And this is solve this inequality. That's the inequality given to you. How would you solve for x? I want to give you 2 minutes to think about it. Okay, I'm going to step out just for 2 minutes. And Farouz, if you could, are you there?
Yes. Yes.
If you can lead them for 2 minutes. Okay, I'll be right back.
Okay. So anybody has question, bring it up on the chat or unmute and discuss it. You can break it down to steps and then, create questions. Say what I'm going to do. Sine x. Instead of saying greater than 0, right? You can break it down to sine x equals 0 and think about the question. Sine of what angle equal 0? Any suggestions? Any volunteer respond on the chat or unmute and say something about it. Sine of what angle? Sine x equals 0. Sine of what angle is equal to 0? Could be, answer could be in degree or radian, doesn't matter here. So then from that perspective, you can build up again, think about the original question, which is sine x greater than 0. So for what values of x, sine of x is going to be greater than 0. how high the output can be. Sine of x is 0, right? If x is 0, sine of x is 0. If x is pi over 2 or 90 degrees, sine is going to be maximum of 1. So sine x greater than 0 could start from any place from 0 degrees, 0 radian, up to pi radian, 90 degrees. Professor, you're back.
I'm back. Thank you.
You're welcome.
Are you done?
I just was trying to build up some ideas how they can break it down, the question, simplify it and think about it, visualize in their mind based on what we have learned so far. Just, warm up our brain cell regarding what you are going to teach us.
Okay, so I'm going to share this idea with you. Okay, sine x. Okay. So here, algebraically, you cannot factor, right? Right? How much algebraic manipulation can you do? Very little. But if you look at the picture of sine, what do you see? You need to understand the nature of the question, don't you? You need to understand the nature of the question, don't you? What is the nature of this question? Input. We want to find input such that the output is what? Such that the output is what? Output positive. Yes? So in this picture, where do you see positive output? This piece is positive, right? So what are the input to make it positive? Right? Yeah? You guys see that? You see how visual that is? Two circles. So between these two numbers, the output is positive. And what else is positive? That piece is positive, right? So you need to identify all these positive pieces. Yes? So what are the input that will make the output positive pieces? Well, you can identify those pieces, right? This is another piece. How many pieces do you think you're gonna have? Infinite, right? So all you need to do is identify the crossings. What are the crossings? The crossings are x-intercepts, right? The crossings are x-intercepts. You guys follow me? Once we identify the x-intercepts between the input in between, for example, what will be the input in between? If we have a graph sign, right? So what will be this interval? That's from 0 to pi, right? And the next interval is what? It's from 2 pi to 3 pi, right? That's from negative 2 pi to negative pi. Do you guys follow me? Remember when we did sine? You can also use the unit circle to identify where the blue numbers are 0, right? When the blue numbers are 0, those are the places you have the x-intercepts, don't we? You guys follow me? So that idea, the function perspective, can be very useful when you run out of sources, when you run out of, when factoring becomes difficult, or sometimes even impossible. Turn to function, turn to graph. That's why it's so important to understand the definitional function. What is the input? What is the output? You guys understand what I'm saying here? Right? So what was the input in sine curve? Remember the orange, right? And the blue number, the orange and blue number. The orange, of course, tell you the radians, tell you the radian value. You guys remember that? Now, if you don't know, don't remember what we done there, go back there, and then you connect with this, and that connection will help you. That connection will help you. Okay, so what will be the solution then? Well, that interval is what? What is that interval? What is it? This piece is between 0 to pi. Right? So your solution becomes what? Pieces of intervals. And then you can look for patterns. You can look for patterns, right? So over here, this is between what? Between 2 pi. I know we're not used to these kind of solutions, right? Where we have lots of solutions. We have lots of solutions, right? And over here, what do we have? Negative 2 pi less than x less than negative pi. Do you guys follow me? And then you can look for patterns, right? I'm sure you're going to find a pattern. You can find a pattern. Okay, so here I give you this idea. I give you this idea. And of course, similar ideas can be applied to complicated functions. Sometimes the function is just impossible to factor. Do you have those situations? Yes, of course, I can easily give you a function that's very, very, very difficult to factor. Then what you do? You could have used this method, the function perspective, the function method, as I said earlier. Okay, now I'm going to say it again. In this day and time, right, where technology is so readily available for us, right? A graph is at your fingertips, right? All right, so this is the, I'm not going to expand this too much. Okay, just give you some ideas because I think doing mathematics, right, to finish your academic goals, and one of the things you want to have is that you know some important ideas. Okay, in the field of mathematics, right, there are some very important ideas, but not as many as possible. If you know a couple of ideas, you know a couple of principles, it will carry you a long way. It has carried me through my education, right? So it will carry you a long way until and then you realize this is how I would say how to study, right? How to study. How do you make a thick book thinner? Right? We just have to think a little bit more. Okay. All right, so that's just one question I talk about. And all the other questions will be similar. All the other questions in basic 9 will be similar. Okay, so let's look at another question. Let's look at another question, right? Where we need to make 0, make a product, and look at the function perspective. Okay, do we have time? Yes, we do. Okay, so basic 9. Okay, so this one I will be working with you. I might work with you 2 more or maybe 1 more. Okay, I will see. Okay, number 6. Number 6. Number 6. Okay. Number 6, we have a x squared less than 2x plus 8. How do we solve this inequality? How do we solve this inequality? I would say algebraically, it's how do you do it, right? So let's go straight to the method, right? I leave the thinking for you after class. We only have so much time in class. The first step, make 0. X squared minus 2x minus 8 less than 0. So the first step is making 0. 0 is not given, you make 0. Okay. The second step, make product, factor. I have given you some exercise to make factor. To do factorings in the book, but because factoring was not considered the hardest topic, so I didn't cover. Okay, I didn't cover those in this class. And for those of you who think you might need this, you should grab some. I have some factoring exercises here, definitely, but this may not be enough. Just grab some intermediate algebra textbook or elementary algebra textbook to just have a crash course on it. Okay, factor. You need factoring techniques in Cal. All right. So make 0, make product. Right. So if we don't have 0, we make 0. If we don't have product, we make product. Okay. So if this is true, then that. If this is true, then that. So how do we read this? Read these from one line to the next. If then, if then, if then. So that's very important. We understand this is an if statement. If then. If then. Remember, did I show you that? If then, if then, if. That's how you read it. Right? Then if we use the first method, okay, if we use the method we talked about yesterday, right? You look at the sine of x plus 2. Right? The sine of x plus 2. We already did one x plus 2, right? So let's save some time. X plus 2. Right? So I'm going to try to save some time. X plus 2. We have x plus 2. We know the sign of x plus 2. And today we have x minus 4. So this is just changed to 4. X minus 4. 4. Right? 4. You guys see that? Similar questions. Similar questions. Do you see that? But we have 2 additional steps. One is making 0, the next one is making product. Making 0 comes first. Because the principle number 5, number 6, they all call for 0 on one side. Principle guiding steps. Do you guys see that? Principle guiding steps. Principles guide steps. Okay. Right? Function perspective. Function perspective. Did you guys write it down? Right? Just solve this inequality. Right? This question is similar, right? But I can also make a different question, make it larger than 0, right? If it's larger than 0, of course, the solution will be the less than -2 or greater than 4, right? Similar questions. We're going to run out of time very quickly, so I'm just getting, I'm going to focus on the ideas, right? So if I use the function, if I use the function idea, okay, if I use the function idea, okay, so the second way to do this, did you guys have time to write it down? I'm sorry, I might be running too fast. making zero, making product, observing sign, right? And then just go for it. The next one, if we see this as a function, you probably don't have to do factoring. Okay, let me give you another trick. If you don't like to do factoring, in some cases, like in this case, quadratic, if you see this as a function, right, you can graph the function, right? We can graph the function, no problem. All right. We graph the function. You still need to know the x-intercept, don't we? We need to know the x-intercepts. So here I'm going to make it 7. Right? This is the graph. This is the graph. You still need to know the crossing, but you didn't factor, right? You didn't factor. So what do? You can set this equals to 0, right? Use quadratic formula. Quadratic formula will find you these 2 points. Whether these 2 points are nice and neat or not, if they are, if you have those 2 points, well, sometimes you don't have the crossing, by the way, okay? Sometimes you don't have the crossing. Sometimes quadratic, the curve is above x-axis or below it. Okay, so you can use a quadratic formula, and then you also get x equals to -2 or x equals to 4. Okay, and then you mark the points, right? You mark the points like I showed earlier, right? You mark the 2 points, right? -2, 0, point, circle, another point, 4, 0, and there, right? And you can just do some markings on the picture, right? So this is a plus, and this is a plus, the output a plus, and output a negative. You know, then you're looking for a solution which is less than 0. So the solution is the same. So the solution to that less than 0 are from -2. We're gonna do another kind of example, 2, 4, okay, which is larger than 0. Sometimes that is okay. Okay, so I will do one more, and then we get to the quotient, to 10a. Okay, to basic 10a, basic 10. Is that basic 10 or 10a? Yeah, basic 10. I didn't give 10a. Okay, there are more exercise afterwards. There 10b and so on and so forth, but I didn't make a 10a. So 9, basic 9, basic 10. Okay, one last one. This will be more general. This will be more general. Okay. So this one I want to work with you is number 19. We do number 19. The reason I choose number 19, okay, basic 9, number 19 is because it doesn't factor easily. Okay, and also because it's larger than 0. Okay, we want it to be greater than or equal to 0. We don't need to make 0. We already have a 0. But factoring is difficult. Factoring is difficult, right? So we can go to the graph. We can go to the graph. And here's the graph. Here's the graph. And it's very difficult to identify it's hard to identify the point of crossing, isn't it? It's very difficult to identify the point of crossing. Okay. So here I'm going to make it -3 to see if that works. Okay, so -4. How about that? We don't need that much. Okay, 3. There. It's very difficult to identify the crossing, right? So this case, you have to use a quadratic formula. You have to use a quadratic formula. Okay, so we have 2 points. So first, you're going to try to find the, we're going to set that equals to 0, right? So you're going to set equal to 0. When we set it equal to 0, what are we trying to find? We're trying to find x-intercepts, right? We're trying to find x-intercept because we want to find these 2 crossings. We want to find these 2 crossings. And in this case, you have to use a quadratic formula. Factoring, it's difficult. I'm not saying it doesn't exist. It's difficult. Okay, you can still go for factoring though. Okay, I can assure you the factors exist. You don't want to spend too much time there, right? You don't want to spend too much time there. So whatever tool you have available, so we use a quadratic formula. Do you guys know quadratic formula? Some of you can sing a song about it, right? So 2a, 2 times 2, minus b minus 4 plus minus 75%, right? Plus minus square root of b squared, that's a 4 squared, minus 4 times a is 2, c is 1, right? That quadratic formula. And simplify. Okay, negative b plus minus root b squared minus 4ac, 2a. Okay, if you don't know quadratic formula, you know, make it up. Hopefully, you know, make it up somewhere. This is 5 courses in 1, so I don't know which, you know, which part need to be mended, right? So here we have 16 minus 8. 16 minus 8 is 8, right? And then you just simplify a little bit. So you have a 4 in the denominator, negative 4 on the top, plus minus 2 times root 2, right? Reduce. So you have 2 minus 2 plus minus square root of 2. So you have 2 x-intercepts. Okay, so x-intercepts, 2 of them. Okay, one is negative 2 minus root 2 divided by 2 comma 0, and the other one is plus comma 0. Okay, so this way you have to find, because your professor wants you to do the, you know, the precise value, right? Here you go, you got the precise value, and the inequality, right? So we're going to put the dots there. This time is going to be dot. So these are the 2 dots on the curve. These are the x-intercepts. These are the x-intercepts. Okay, so what are they? The inequality we're solving, is greater than or equal to 0, greater than or equal to 0, okay? All right, so larger than 0 or equal to 0. So what are the pieces that are equal to 0? Well, there's 2 dots that's equal to 0, right? So these are the 2 points. Whoops. Okay, right here. This point, the output is 0. This point, the output is what? Is 0. Larger than 0, positive piece. So where do you find those output? Where do you find those input such that the output is a positive or 0? Well, so here's the solution. The solution would be x less than or equal to -2 minus √2 divided by 2, or x is larger than or equal to this piece, i.e. the solution are these 2 pieces. Okay, the solutions are these 2 pieces, this piece or that piece. Did you hear I said the word or? That's the solution. That's a solution. Okay, so I won't have a lot of time for you guys to ask questions in class. You can ask me questions after class and maybe watching the videos over. Okay, next I want to hit basic 10. I want to hit basic 10. Is that clear, everybody?
Mm-hmm.
Okay, basic 10. Quotient. Quotient. Okay, the first example I want to work with you is this, is the first question. The first question in basic 10. We have x minus 3 over x plus 2 plus 1. And we want it to be greater than or equal to 0. This is still an if statement. Okay, this is still an if statement. If statement. Okay, what kind of if statement? It basically says, well, if this is what is at least 0, find all possible solutions. Or find all possible values to make it true, right? So the narrative is the same. The narrative is the same. Okay. So how do we view this? We view this as a quotient, A divided by B. And then we will apply the principles of what? Principle number 5, principle number 6. You guys see that? Right? The idea is absolutely similar, absolutely similar. Okay, so we're gonna look at the sign of x plus 1. Okay, how does the sign of x plus 1 behave? Right? Well, x plus 1 changes sign at a -1. Right? When x equals -1, x plus 1 is 0. Right? It's 0. And when you pick a value, when you pick any value, plug in x plus 1. If that value is less than -1, x plus 1 is going to be negative, right? If you pick a -2, you plug in -3, you plug in, you're going to get a negative number. And we only care about the sign. We only care about the sign, right? So in this case, we get a bunch of negative sign here. Okay, come back 0. Okay. If we pick -1, we get 0. If we pick larger than -1, x plus 1 will be what? Positive. Right? The same idea. The same idea. Okay. So how about the sign of x minus 3? Well, for x minus 3, when does x minus 3 equal to 0? When is it equal to 0? At 3, right? Right, at 3. So when we choose a value less than 3 and plug in, we're going to get negative. The sign is going to be negative. At 3, it's going to be 0. At 3 is going to be 0. Larger than 3, when you choose a value larger than 3, it's going to be positive. Same idea. Same idea. But there's some tweaks. There's some variations. What is it? Because we're dividing by x plus 1. So when the denominator is 0, we cannot divide by 0. So in this case, when we observe the sign of the quotient, so when we observe the sign of the quotient, what will happen? You still have the number line, right? We have the -1 here. We have the 3 here. Okay, -1, 3. Right? When we pick a value from less than -1, between -1 and 3, or larger than 3, we plug in these numbers into each interval. Okay, and these intervals are divided into 3 pieces. 3 pieces, just like what we did yesterday. When we pick this number less than -1, we're dealing with a negative divided by a negative, right? X minus 3 is a negative here, right? Because you're going to put the same number there, right? You pick this number here, you pick that number there. You get negative divide by negative. Negative divide by negative, what do we get? We get positive, right? Yes? Negative divide by negative, we get positive. In between -1 and 3, we have a negative divided by positive. So in here, we're going to have what? Negative. Larger than 3, we have a positive divided by positive. So positive divided by positive, that's positive. Now, how about at the crossing? -1 and 3. At 3, when x is 3, 3 minus 3 divided by 3 plus 1. 3 minus 3 is 0. 0 divided by 4 is 0. So here is 0. But what if x is equal to -1? What will happen? -1 minus 3 divided by 0. when we divide by 0, the quotient is undefined. So we put an infinity sign there. Okay, or you can put NA, whatever, you put an infinity sign there. So what will be the solution, right? So when will the quotient be positive or 0? So when do you find those solutions? You find the solutions here, right? Positive, not including -1. And you also find the solutions here. Those are the input, make the quotient positive, and including 3. 3 is included because 3, when x equals 3, the quotient is 0. And is 0 is okay, is part of the if statement. Okay, so finally, what is the solution? What is the solution? So solution to the quotient greater than equal to 0 are what? Are x less than -1 or x is larger than or equal to 3. So these two pieces. Okay, these two pieces. Then you say, well, are there a function perspective here? Yes, there is. The only thing is that graphing, if you don't have a calculator, graphing this function is a little bit, it's not that trivial. Okay, you have to be careful. Okay, you need to determine the domain and all these other stuff. Okay, but yes, you can. Yes, you can. Okay, especially if you have technology. If you have technology at your fingertips, right? So you can graph this. You can also use a function perspective for sure. Okay, but when you graph this, I would say some software may do justice for you. Some software may not. But usually the academic ones are decent, but you still have to have a critical eyes about what you're getting. Okay, you still have to have a critical eyes about what you're getting. Okay, so let me grab this, let me make some adjustment, right? Let me make some adjustment here. So maybe here I'm gonna make it 8. -7. Okay, you see there's a vertical asymptote here. There's a vertical asymptote, if you understand, there's a vertical asymptote. Okay, that vertical asymptote is there's a vertical asymptote. Wait, well, that should be broken line. Okay, there's a vertical asymptote, and that's -1. So you can see that piece is a positive, but this piece, you have a negative piece, you have something negative, you have something positive, and there's a crossing. So you have to identify this point. So you still need to identify the points. -1 is a vertical asymptote, that's where it crosses. Right? The solution cannot include a -1. But here you need to identify that point is 3, 0, which is you to find x-intercept as well. Okay. So this is suppose you get the graph right, whether by technology or by your sketching by hands. You can still use the function perspective. Okay. So of course you can also set this equal to 0 and solve that you get x equals to 3. But I'm not going to spend too much time here because there's another issues I want to talk about. There's an important issues I want to talk about. Okay, so once you can identify this point, you can identify the solution, right? So you also get the same solution. The solution will still be, you know, idea the same, okay? So I'm gonna move forward to talk about some of the common mistakes in this area, okay? That's where I want to get to. Hold on, wait. Okay, so now let's look at, oh, time is running out. Oh my God, it's 9:22. We gotta hurry. Okay. Basic 10, number 2. Could I use a little bit extra time? Maybe 10 minutes? Okay. 3 plus x over 3 minus x greater than or equals to 1. Right? In these kind of questions, if you want to solve it, you still need to make a 0. But sometimes people don't make 0 and make terrible mistakes. So for this question, I'm going to start with a common mistake. Okay, I already told you this is a mistake. But this mistake looks looks right, looks almost right, but it is not right, okay? People will typically do multiply the common denominator. Multiply 3 minus x on both sides, and this student will get 3 plus x, right? Greater than or equal to 3 minus x. And then blah, blah, blah. Then blah, blah, blah. Do you think this might be something you would do? I want to tell you this step is wrong. This is the wrong step. And you're going to tell me why. I'm going to leave you guys for 2 minutes, okay? Farouz is going to lead the discussion for 2 minutes. Why this step is wrong. Okay, I'll be right back.
I'm here. Anybody want to discuss it on the chat or
It's
on
a very common mistake, but it's a terrible mistake.
any suggestions on the chat? Unmute if you want to discuss it. So she could show us previous question that for the rational inequality identical. But previous question, it was solved, right method. So comparing with that, you can find the answer why it is wrong. why it is wrong. So,
Why it is wrong.
okay.
Thank you, Bruce.
You are welcome.
I apologize, and I'm preparing for surgery tomorrow. So this morning I had to drink some stuff to clean up my system. So I will not be eating today and until after the surgery. But anyway.
The reason it's wrong is because it's an or statement, right?
I'm sorry?
The reason it's wrong is because it's an or statement.
No.
Okay.
It's not an or statement. It's just it is an if statement. Okay. The reason is that is because we don't know the sign of 3 minus x. Okay. You see, when we solve equations, right, we have principle number 3 and number 4, right? You can multiply both sides by a number not equal to 0. That's fine. But for inequality, there's an additional requirement, which is, right, for example, if you have negative 2x larger than 1, what will be the next step to solve this inequality? You divide by negative 2. What will happen? You have to switch the direction of inequality sign, right? Right? You guys know that? I assume you guys know that, but I will explain to you if you don't. We have principle number 3 and number 4, right? Especially number 4. You can multiply both sides if A is the same as B, right? Okay, so if, let me write down the statement of principle number 4. If A is the same as B, right? Then you can multiply A with C equals B with C, where C cannot be 0. If you do that, you're good. Right? That's principle number 4. But if you have A less than B, then if you do the same thing, this is true, this is false. Have you guys learned that? Okay, this is true if C is positive. That will make it true. So if you divide or multiply by positive on both sides, you will keep it. You keep the same direction. Okay, so let me give you the example here with a parallel comparison. Okay, so if you have negative 2x greater than 1, your next step will be x is less than negative half. You're dividing by a negative number, you need to switch the inequality direction. But if you have 3x greater than 2, right? You divide both sides by 3, you have x is larger than 2/3. You keep the same direction. So when you divide by positive or multiply by positive, it keeps the same direction. But if you multiply or divide by negative, okay, if C is negative, A times C will be larger than B times C if C is negative. Okay, so the same statement would not be true. Why is that? Why is that? Why we multiply by negative, we have to switch? Tell me. Anybody has any ideas? It's all because of number line. It's all because of number line. We have a number line here. Okay. And here we have a 0. This is 0. Okay, we have a 0 here. Oh. I'm just going to, oh wait, sorry. Okay, so here's the number line. Okay, and here's the 0. On this side, right, on this side of the number line, right, we can say 2 is less than 3, right? 2 is indeed less than 3, yes? Yeah? Do you agree 2 is less than 3? Are you guys with me? But if you multiply negative number on both sides, if you multiply -2 with -3, what do you say? -2, -3, which one is larger? -2 is larger, right? This is why you have to switch the direction of inequality sign when you multiply by a negative number for inequalities. Larger than, smaller than, greater than, or equal to, less than or equal to. Okay, so now let's go back to our original question. We know that x cannot be 3 for sure. We can guarantee that because domain requirement will make it happen. But we don't know 3 minus x is positive or negative, right? If 3 minus x is positive, then we don't need to switch. But if 3 minus x is negative, we have to switch. So do we switch or we don't switch? That's why this step is very, very popular, but it's terribly wrong. Do you follow me?
Yes.
Okay, so I'm going to move fast. I'm going to move forward, but this is a very, very common mistake. How common? There's one semester I was on medical leave again, okay? A couple of years ago, my substitute taught this way. When I came back, I have to make the correction all over. So some of us, some of my peers may not have noticed, or they may not have think too much about doing this. You follow me? I'm not saying your substitute will be doing that. I'm sure there's no problem here. But you need to keep a watchful eyes about what your teacher do. Don't think they're always right. Including myself. I'm not always right, okay? I'm not always right. I make mistakes. You need to make sure, because ultimately you are going to bear the responsibility. Be critical. Would be critical not to people. Okay, I always say that. Not be critical to people, but critical to the work. Right? Especially mathematics. Right is right, wrong is wrong. You can never make right wrong. You can also never make wrong right. All right? So now, after we point out this mistake, right? So never ever do that. So what do you do to solve this inequality? Make 0 first. Does that sound familiar? Make 0. So -1 greater than equal to 0. Make quotient. Sometimes we make a product, sometimes we make a quotient. Okay, we make quotient. So how do we make a quotient? We have to find common denominator. Okay, I'm sorry. You have to do this. Basic skills. Make a quotient. This is not a quotient. This is a 2 quotient. You're gonna make a 1 quotient. Because only after you make a 1 quotient can we use what? Can we use principle number 5 and number 6? Principle number 6. You follow me? Now go back to look at principle number 6. 1 product, 1 quotient. Okay? When you look back and forth, you look at the principles, you will have so much appreciation for those, you know, self-evident principles. Okay? Now let's finish this, okay? And some more algebraic manipulation. We have 3 minus x in the denominator. We have 3 plus x minus 3 minus x. And that's greater than equal to 0. Okay? And next, you simplify further. Well, we're closer to 1 quotient, right? Make 1 quotient. So 3 minus x. Then you open up the parentheses, 3 plus x minus 3 plus x greater than equal to 0, right? So how do you read them? If then, if then, if then, if then, if then, right? If then, if then, if then. That's how you read it. If then, if then, if then, if then, line after line. Okay? And now we can reduce it because 3 minus 3, that makes 0, x plus x as 2x. 3 minus x greater than or equal to 0. 1 quotient. So now we can practice the sign, right? So you're going to work on the sign of x. Then you say, how about 2x? What the x is and 2x the same sign, right? You can also divide both sides by 2, as a matter of fact. If you like it, you know, cleaner, like right? Divide both sides by 2. 2 is a positive number. No need to switch. Okay, so what's the sign of x? Well, sign of x changes sign at 0. Right? That's easy. This is the easiest. So the sign of x when x is negative, when x is smaller than 0 is negative. When x is 0 is 0. When x is positive, it's positive. Okay? And then what's the sign of 3 minus x? Sign of 3 minus x. Sign of 3 minus x. This time, okay, so it changes sign as 3. Okay, it changes sign as 3. So let me make this a little shorter. Oh. Anyway, okay, so this is 3. All right, 3. When x is less than 3, 3 minus x is positive. Agree or not? Yes or no? Do you agree with me? When x is less than 3, so you pick -1, right? 3 minus -1 is 3 plus 1, so you're going to get positive, right? When x is 3 is 0. When x is larger than 3, 3 minus x is negative. And then you look at the sign of this guy. So finally, sign of the quotient. Okay, what's the sign of the quotient? Three intervals. Once again, 3 intervals. Right? So over here, that's my 0. Over here, that's my 3. Right? At 0, at 3. When x is chosen to be less than 0, right? Less than 0, we plug in. We're doing negative divide by positive. Negative divide by positive, what do we get? What do we get? We get negative, right? What happened at 0? When x is 0, what happens? When x is 0, 0 divided by 3 minus 0, that's going to be 0. Okay? How about between 0 and 3? If I pick a number between 0 and 3, what happens? We have a positive divide by positive. Positive divide by positive, what do we get? Positive. Right? Positive divide by positive is positive. What happened at 3? When x equals 3, what happens? There's 0 denominator. So in this case, undefined. After 3, when x is larger than 3, when x is larger than 3, positive divide by negative. Positive divide by negative, the quotient will be what? Negative. So eventually, our if statement is if the quotient is greater than or equal to 0, where will make that happen? So the solution would be what? Include 0 less than 3. That's the piece. This is the piece. Okay, so that is a piece. That's our solution, including 0. All right, I think I have covered enough. I have gone over. I'm sorry. With much regret, I will not be able to finish teaching this semester. I hope I have helped you, and I wish you sustained success. And I hope to see you guys sometime in the spring semester. And I urge you guys to continue to work hard, to study, and to prepare yourself well, and make it a very good grade in calculus. Okay, and thank you for all of you guys' patience with me and understanding. And some of you sent your well wishes to me, and I really, really appreciate that. So tomorrow I will be in the hospital. And after the surgery, I will be resting. Hopefully I will recover soon. And I'll miss you guys. But
Thank
Farouz
you.
will be with you guys still.
Thank you, Professor. I wish you well for with your surgery.
Thank you. I'm hoping for the best. I wish the best for you all. Thank you very much. I will miss you. But tomorrow still come to the class, the same time, the same link. Thank you, Mark. Thank you, everyone. Okay, I appreciate it. And have a great holiday.
Thank you, Professor.
Yes.
Hope everything goes well.
Thank you very much. Thank you, thank you, thank you.